Okay, so the first one is the segment addition postulate. And they're going to give us a little bit of information. And the best thing to do would be to draw a diagram. So Q is between P and R. I'm just going to draw that situation. There's P, there's R, and there's Q, somewhere between P and R. Okay, now let's just label PQ is 3x, represents 3x units. QR is 16, and the entire length of PR is 14x minus 6. And I just put the little bars with the arrows. It's helpful for me. Okay, so the first thing we do, and most of you know this, is to set up that equation. We know that the segment addition postulate gives us PQ plus QR is the entire length PR. So I'm just going to say PQ plus QR equals PR. I'm just plugging in the expressions for the terms for each of those segments. Now we're ready. All you've got to do from here on out is solve for x, plug x back in to what we're looking for. So let's solve for x. Let's get those x's together because they're on both sides of the equation. So that just gives us 16 equals 11x minus 6. Carry the 6 on over to the other side because now we want to solve for x. And that gives us 22 equals 11x. Divide by 11, and we've got x equals 22 divided by 11, 2. I would put a line under that. On your quiz, if you got this correct, that's 1 point. If you got this correct, solved for x correctly, that's another point. Now we're just looking to see what to do with that x, and they want us in the quiz, they asked us to find PR. So they want the entire length of PR, but now we know what x is, so we can find PR. PR equals 14 times 2 minus 6. And we know that that's 28 minus 6, and PR, our final answer, is 22 units. There you go. Here we are with number 2. Number 2 is also a segment problem because we're looking for the midpoint of a segment. And we're given some information and we can easily draw a graph from that because I like to see what's going on. So let's just see. We're using midpoint. B is the midpoint of AC. Pretty easy diagram to draw. B is the midpoint of AC. I could put little ticks there just to show us that that's what the statement told us, and that's showing that AB is now congruent to BC. So let me just put AB is congruent to BC. That would be a good congruency statement to write before solving the problem. Now, a few of you had a little bit of a difficulty with this one because there's something you had to think about, and we did this in the homework. So I wanted to make sure you remember this. AB is 8V, and the entire length of AC is 2V plus 42. Now we know that these two are equal, and also if you double them, you would get the entire length, or if you added this expression to this expression. And I saw some people were trying to figure out, well, what can I put to represent BC here. And that would be a great idea if you just, because AB represents 8V, what can BC represent? AV as well. Sounds good to me. So now we know that these two segments, or if we double those segments, we will get this segment, or now we can just add them. So let's do that. 8V plus 8V equals 2V plus 42. That's 16V equals 2V plus 42. And now we get those V's together. Get those V's together. 14V equals 42. Now I know from vast experience that 42 divided by 14 is 3. That's our magic V. Now, we've got the variable. This was a very important point. If you showed your work but you got this initial equation wrong, I probably gave you 1 or 2 points, depending on how neat your work was. You made a mistake in the beginning, but that's okay. We're still trying to accumulate points based on that. So we've got V equals 3, but we're looking for BC. BC is 8V, which is also the measurement of AB. BC is 8 times 3, 8V, and BC equals 24. There you go. So we know 24 plus 24 is 48, and now we're really getting good at math in our head. So 48, 2 times 3 is 6 plus 42 would be 48. Check. Y'all ready for number 3? Number 3 looks really tricky unless you can read and draw the diagram. And then after that, and knowing something about angle bisectors is really important. And I think you all know that if you see that something is bisected, we know that it is cut in half. So we're going to cut this angle in half. And so whenever you're dealing with an angle bisectors problem, just draw the diagram if it's not there and start to label. So I'm going to say ray GJ bisects an angle FGH. So I should draw an angle FGH and then bisect it. So that's all we're doing. So I'm going to draw a nice large angle so I can see it. That's an acute angle, but it's enough for our representation. So what we can do is label that F, G is the vertex, H, FGH. We just drew an angle FGH. And now we can say GJ, see how that nicely has an endpoint of a ray, and we can put a J on it. So if you drew that diagram and really showed a good understanding, you probably got a point. Now, I'm going to label FGJ. Now we've got FGJ, and this small angle in here is 7x minus 9 degrees. And this angle right here, HGJ, represents 2x plus 36. Now these problems tend to have a pattern because if something is bisected and we give the representation of the two smaller ones, we know that we can set them equal, right? So let's set them equal and go from there. So we know that these two angles, because this angle bisected them, are equal. 7x minus 9 equals 2x plus 36. If you made the mistake of just adding those, then you didn't know really what they added up to. We can set them equal right off the bat. Don't try to add them unless they add up to 180 or they're supplementary or they add up an angle addition postulate. But right now, they're just equal. Okay, so here we go. Negative 2x or minus 2x. 5x minus 9 equals 36. 5x equals 45, and x equals 9. I did that fast because you guys are algebra experts. So now we're going to take that x equals 9, and here's a little bit of a tricky part. They're asking for the measurement of FGH, so they want the entire angle. Now you got 3 points if you substituted x and got one of the smaller angles, but forgot to double that angle. You've got to double that because they're asking for the total. So I'm just going to pick one of those angles and say, let's say FGJ equals 7 times 9 and then subtract 9. That's 63 minus 9. And what is 63 minus 9? Angle FGJ equals 54 degrees. Now, if that was your final answer, you almost got it. I was so excited for you. You missed it by 1 point because you really have to double that, because the measure, the angle that we're looking for, FGH, is 2 times the measure of that angle, and the magic number is 108 degrees. Last one, you can do this because we're talking about the angle addition postulate. And you know that when you see two smaller angles that are adjacent to each other, those two smaller angles add up, their measures add up to the larger angle that they create when added. So we know that this angle here, EFG plus GFH, this plus this, equals the entire angle. Now, they're looking for EFG. That's okay. We know we need to get an X in there and find it. But we have some really valuable information. The valuable information is right here. The entire angle adds up to 111 degrees. So we can use that information. Doesn't that mean that this smaller angle plus this smaller angle, their measurements add up to 111 degrees? One thing I want to say, because you're watching this video now, is sometimes I'll give you two angles and I'll say they are supplementary. And if I say they're supplementary, they don't add up to 111, they add up to 180. Or if they were complementary, and you use that keyword, they would add up to 90. But this one, they are not supplementary or complementary, but the problem is similar because these two angles add up to 111 degrees. That's the theory. Now let's do the number crunching and the mechanics. So here we go. 3x minus 20 plus 3x plus 5 equals 111. Now this is an algebra thing that all our experts know. We're not moving x's yet. We're combining them, combining like terms. So all I'm going to do is combine like terms. 6x negative 20 plus 15 minus 20 plus 5, is minus 15 equals 111. That's pretty good. Okay, so we've got now add 15, and 6x equals 126. Divide that by 6. 6 goes into 12 2 times, 6 goes into 6 1 time. X equals 21, our magic X. Now we can come on over here, take that X, they want EFG, so we can plug that right on in, and the measure of angle EFG is 3 times 21 minus 20. 3 times 21 I know because I've been doing this for a while. 63 minus 20, and that equals 43 degrees. You could check yourself because you got a lot of time because you've been practicing this all a lot. If you plugged in x equals 21 to this angle right here, you should get something that's going to add this 43 to get the 111, something like that. That's the way I think about it quickly. I didn't express it very well, but you know what to do. Have fun. Practice these 4 problems and be really proud when you can do them on the test.